In this video, we'll be covering the basics of inverse functions. This first question is, find f follows g of x and g follows f of x. Use this to determine if f and g are inverses of each other. Also at the end, if these two functions are inverses of each other, we will be using the appropriate notation to identify inverses. So, recalling what these two things are here, f follows g and g follows f, we're going to be going ahead and finding out what f of g of x is. Again, recalling that this is the notation for f follows g of x. Those two identifications are actually the same thing. So relatively quickly, we're going to go ahead and take the function that is g, we're going to plug it into the function that is f. So this right here is my function g. Everywhere in f, we're going to replace that x with that entire function. So we're going to have 7 parentheses x minus 4 over 7 plus 4. This here is again replacing all the x's in f with the function g. Next, what we'll do is we'll simplify this as best we can. This is 7 times this entire fraction. Since it's 7 times this entire fraction, this 7 can cancel out with this 7, leaving with x minus 4 plus 4. Notice how I've dropped the parentheses because they're not actually necessary with this being a plus sign. Next, we can go ahead and combine like terms such that negative 4 and positive 4 cancel out, and we get f of g of x equals to x. Secondly, if I take g of f of x, again, which is just simply g follows f of x, and plug the f function into the x for g, we will end up with 7x plus 4 in parentheses minus the 4, this whole thing divided by 7. Now in this case, I can't cancel out these 7's at this moment because again, there's more stuff on top that I have to deal with. However, I can drop these parentheses and combine like terms on top, giving me 7x plus 4 minus 4, which will cancel each other out, divided by 7. So 7x over 7 is nothing more than x. So, in both cases, plugging f into g or g into f, vice versa, you will end up with getting that function getting x back. So the idea here is this. If for g, I were to take x and plug it in here, so say I were to take 2 and plug it into this function, then that number would then spit into f, so whatever I get back from g of 2, that goes into here, and when I simplify this, that's going to give me back the original x value. So the idea is, if I were to plug a number in for g, plugging that number into f will spit back the exact same number I plugged in. If this works in both directions, then we can identify that g and f are inverses of each other. And the way that we would generally write this in terms of notationally is g is equal to f inverse, or more appropriately, g of x equals to f inverse of x. We can also make note that f is equal to g inverse, or f of x is equal to g inverse of x. Now make note, this is a notation, this is not a power, so this does not imply that this is equal to in any way f of x. If we recall that a negative power makes it a fraction. This is not a power. This is a superscript that's representing a notation for the inverse function. So f inverse of x is equal to the original function g, x minus 4 over 7. Again, this is notational, and this is identifying f inverse. That's how we determine whether or not two functions are actually inverses of each other. This is the actual notation to determine that this is going to be an inverse. And lastly, these must both be x. They don't have to necessarily be x plus 2, they have to be x. So if we get back, say, x plus 2 here and x plus 2 here, it doesn't mean they're inverses. They cannot be inverses. It must be equal to x for there to be inverses.